G'day and welcome back to part 2 of my 1936 Bush VP5 battery radio. In part 1 it became obvious it was a battery set, but after a clean up and a cobbled together power supply and a bit of a fry up, the radio was working. This week I'll attempt to make a bespoke power supply to power this rather unique radio. Right, I'm going to have a go at making a power supply for this radio. Because it runs at 144 volts, it's difficult to get a battery illuminator to suit, and if I can, or the one I can get, is going to be too expensive for the owner. It's too expensive for the radio. So I'm going to have a go at making my own. I thought of a lot of different ways of doing it, but I want to have a transformer in there so it's isolated from the mains. I don't want what would effectively be a hot chassis radio. So I've got a mains transformer here. I've pulled one out of an old radio and I've taken the core out. Now this transformer's got mains in. It's got a centre tap secondary, that's those three. It's got ground and it's got two for the filament. Now this is a step up transformer, so you put in say 240 volts here and it puts out, I think it was about 270. I've got it written here, 267. The primary is the first winding. So I think what I can do is I can use half of the secondary, not like from one centre tap to the outside, and take out the first layer of windings up to the centre tap. So that'll give me 260 out. So with 240 going in, 267 coming out, that means the ratio is 0.900. That means that for every 1,000 turns on the secondary, there's 900 on the primary. Now I need to reverse that. So I need to make it 1,000 on the secondary, there's 1,714 on the primary. Now because the primary is underneath the secondary, I should be able to just peel off enough wire to get this ratio. And I can use the first half of the secondary that I'm going to take off to count the turns. I bought one of these Chinese winding machines. I have the electric model, but there is a manual one. I probably should have gone for that. The reason I went for the electric one is it's got a foot control, so I thought that'd be good. That frees up two hands. But it's only got 3 speeds. It's got 0, extremely fast, and unbelievably fast. So it's not as what I'd hoped. I thought you could gradually just wind it up, but it doesn't. It's just on or off. Now the core I've got off the old radio has a big square hole in it. There's no provision for this to be winding big ones like this, so I've made up some little formers to go on the end. This also on its bobbin doesn't have any sides on it, so that's another issue that I've got to tackle. I should be alright though, so I've made this up and it should click in. There we go. And I'll put the nut on the top. The shaft just goes on here and held on by an Allen key. I have it mounted, so I just take off this top layer of paper and take off the top layer of wires too. I don't need them. This is proving difficult to get off, so I'll just try and unwind the big wires there. That should just about peel it off by itself. Okay, there's the end of that wire. It says I wound off 40 turns, but I don't know if I zeroed that. I wasn't that interested, but I'll write it down anyway because it might be useful as a check. I'll see if I can get the next layer off, and that should be the start of the secondary. And there's one there. Yep, that's the first one. Okay, I can't get this off. It's stuck on. It's like getting an epoxy off. There's an epoxy, of course, but I can't get it off. So I have softened it with the heater here, the gun, and I'm hoping that it will let me get it off. Now what's happened, I've tried to use a chisel to get it off and all I've done is broken the wires. Now I don't know where anything is. So this is not going to my plan. So I've completely lost that wire now. Oh, this is just not working like I hoped. It seems to be working now. Once it's got a start, it's peeling off that black lacquer, whatever it is, and it's doing it one bit at a time. It seems to be okay. I've taken the belt off the drive there, so I can just pull this wire out. I'm on the second layer now, so it's coming off easily now. We've got about 430 something turns. It's probably couple of thousand to go. Looks like I've come to the end of it. There's the centre tap wire there, so That's running along there, and I think I've run out of wire. It's come up to 1620. I might have lost a few turns there when I was breaking wires and things, but it's pretty close. Now I need to work out what the new ratio will be for that remaining bit of the secondary. So 1620 was the secondary that I took off. So I need to multiply that by 0.9, which was the ratio between 240 and 267, so that's 0.9. So 1620 multiplied by 0.9 equals 1458. So that means the primary is 1458. So to get the primary 1458, we divide it by 1.714. So 1458 divided by 1.714 equals 850. So I need to be left with 850. So let's see, 1620 minus 850, 0, 10, 5, 7, 917. I need to remove 770 turns. Here's the center tap, so I'll just follow that along and we should be able to retrieve the wire. There it is. So I come back there, 0. It got a bit hard there, so I've set my heater up again just to heat that bit up. Let's see how we go. So there it is, 770. I'll put a little bit of tape there just to hold that while I clean everything up. I'll replace the masking tape with some of this polyamide high temperature tape. I've cleaned off the enamel, I'm just wrapping it around this wire. I'm going to solder that on. And I'll put some more of this tape around. I'll put some around there as well. I guess that'll help. I'll put a bit around the centre here as well because I've got to run the little filament wire on. So I'll make sure it's insulated from the one underneath. I'm going to add a filament winding as well. I want to run it at about 6 volts and then I'm going to use a regulator to drop it to 2. So if I get my 240 input voltage and divide by 6 equals 40. So 40 to 1. The primary is 1458, divide that by 40 equals 36.45. So 37 turns for my filament winding. Alright, back to the coil. I've put a wire there and the winding wire I'm going to use, it's about 0.5 millimeter diameter. I think it's 0.6 of a millimeter. So I'll do the same again. So I'll reset my counter and I'll just wind this on by hand. If I put the motor on, it's going to go mad on me. So nearly there, 36, 37. Oh no, one more to go. Oh, okay, there it is there. We'll do one more. Alright. I've tinned that bit of blue wire up and I've taken the enamel off the winding wire, So I'll just solder it up there. And once again, I'll put some tape on here. Another one down the middle. Now I've put Kapton tape all around there, and that looks pretty good. I knocked the camera, so I think I've lost the film. Anyway, I'll take this off and I'll go and mount it back in the transformer, and we'll see if it works. I've assembled the transformer again, and I'm just going to test it. I added a bit of fish paper before I put it all together. The primary is connected to my Variac here, and the secondary I've got on my meter. I'll put the switch on. The Variac's on 0 volts. We've got some voltage there. That digital multimeter is reading the secondary. Here we go on the dim bulb control. So I've got 100 volts, 72. Yeah, that's about right, isn't it? So 240 I want on the dim bulb, and 140 on the digital multimeter there. Oops, I've gone too far. I'm looking at the wrong one. 140, somewhere around there, and it's 140 on there. The 240 I was trying to say, 140 there. It's one dim bulb, but that's not going to make any difference. That is absolutely spot on. It's absolutely perfect. I can't believe it. I'll just turn it off. I'll connect these blue wires here. These are the what's going to be used for the filaments, and they were 6. I want 6 on that. Doesn't really matter on that. I'll just turn it on. I'm still on 240. Oh my God, look at that. 6 volts. Exactly. That's amazing. So all that mathematics, and it worked out right. Brilliant. Okay. Now, of course, these are funny figures. I don't know if that reads RMS. This is reading RMS, I think. It actually doesn't say RMS. Yeah, I'm not sure what it's reading. But it won't matter. That radio is going to run, it'll probably run down to 100 volts without any problems. I'm really excited. This is amazing. I never thought this would work. So I need to come up with some filtering for the HT, and I need to come up with some filtering and a regulator for the low tension side. So that'll be the next bit. Before I go, I'll just say about this winder, it's pretty good. Like I said, it's really fast. That's the only thing. I think it does 2,000 and 4,000 RPM. So I guess if you had it all set up, that'd be fine. But I'll just try it. Yeah, so that's high speed. And that's low speed. So it'd be good if it was gradual. But anyway, now the counter remembers. So if you turn power off and put back on, it's still there. You can reset it. Yeah, so it's really solid. That's a cast case, and I'm quite happy with it. I've spent a bit of time working on this now. I've made a regulator here on the breadboard, and it works fine. It regulates to 2 volts, no problem. And I'm also trying to run the radio off the secondary that I've got on this transformer that I did, but the whole thing is a complete failure. What I should have done is made a center tap secondary, and anyone that knows how to do these transformers and watched me do this probably would have known that. And the 6 volts isn't high enough. It drops off too much with the current draw on it, and drops it below the regulation threshold that this needs to regulate to 2 volts. So it drops down to about, I think, 4 volts or something, or 5 volts. So this thing runs out of regulation room. So I need to increase that to maybe 12 volts. It'll easily take 12. And I think I need to rewire this with a center tap. That'll give me more capacity. It won't drop off as quickly. So I'm not going to show any of that. I'll just go and do it all. It'll just be the same as I did the last time. I'll just wrap another secondary on, and then I'm going to put double the wraps on the filament, and that'll give me about 12 volts. Then I regulate it down to 2, and that'll give me enough headroom. So I'll do all that. I'll come back, and we'll see if it works. All right, there's the transformer all done. I put another secondary on there, so it's got a center tap now. I increased the number of turns on this low tension wire. So I've got everything set up on a breadboard here. This one's just floating in midair. This is the power supply for the 2 volts. This is the regulator section here, and down here is the 144 volts. So that's the rectifier for that. I have it all connected up. It's going to power the radio. I'll put it on. I'll put that on 240 volts. That's what I'm using as the standard. Close enough. and we've got 143 on the main supply, which I'm looking for 144, so that's really spot on. 2 volts on the regulator power supply to the low tension. This one here is just measuring the temperature of the regulator. So it works really well.
Right, and this little partnership here, when you're breaking down the innings, right, we have 14.
Radio #1 in
the radio is working really well. There was a lot of background noise there. That's all gone. The power supply is clean, and all that noise is gone that I was getting off using the soldering station. I'm going to try and fit all the electronics on this board. These are experimental boards, and you can just solder them up and run your own tracks on the bottom. And I'll mount this on a chassis, and I'll mount the transformer next to it, and I've got some lights to put on it and switch and stuff like that. And hopefully I can just fit it in the back of the radio. I've removed all the little clip leads, and you can see it's not that big a deal. This is the regulator here. There's the heatsink with the regulator on there. This is the 2 volt supply, and here's the 144 volt supply. So I've roughed out basically where I want it to go. That one goes there. This resistor goes here. I'll put the 2 volt supply next to it, the regulator next to that, and the 144 volt supply here. I've got plenty of these little heat sinks here, and I made a little clip up, and that fits in there nicely, so I might use that. So I'll transfer all these components onto here, and I'll come back when it's finished. I've finished my power supply, and I managed to fit it all on the board there, no problems. So as I said, I've got the voltages going in there, and they're coming out here. There's 144 and 2. So yeah, it looks alright. You know, this is as good as you can get on one of these types of boards, but they work alright. So I'll give it a try, we'll see if it'll work. The transformer's all connected. I've put multimeters on the 2 outputs here. That's the 2 volt and that's the 144. And up here, that's 144, and this should show 2 volts. So let's see if it works. I've got 240 volts going in. I've got 3 volts there. So I can adjust that 3 volts down to 2. Hopefully, there it is. That'll do. When I put the radio on, it might just pull it down a half a volt or so. But so far it's working. I'll put the radio on, we'll see if that works. I'm all set, I think. I've got all the wires in the right places. So I'm going to put some power on. I'm going to be ready to adjust this 2 volts. And this is the temperature of this resistor. Now this was originally getting up to 115. I modified the circuit as I did this and changed that down to a smaller value. And I took some windings off the transformer. So I'm hoping this will now run under 50, I'm hoping. Alright, I'll put some power on. Oh, there's a radio. I'll turn that off. Oh, that radio sounds good.
I can't believe that sort of what they're going to welcome the Olympics in 22.
Alright, let's see what we've got. 144, exactly what I wanted. 2 volts. That didn't sag at all. I thought it might move a little. I'll just adjust this down to closer to 2. It's only 0.1 of a volt. That's good enough. And I'm really happy to see this running because I'm not an electronics engineer, and I've put it together using old school technology. I think someone with an electronics degree would know a much better way of doing it. But it is working, so I'm happy with that. I wonder what the temperature of that is. 36 degrees. That was running at 115 originally, but you know, I've lowered the value there and taken some of the windings off the transformer, and that's good. That's really good. I'm going to leave this running for an hour or two, just see what it does, make sure no smoke comes out, and make sure nothing gets too hot. I'll put the radio volume up, and I'll come back in an hour or so.
There will be evolution. You know, they're going to, of course.
This has been running for an hour and a half. I'll see how it's going. And the temperature on that resistor is 47 degrees, so that's perfect. That's stable at just under 2 volts now, and 140 on there, so that's dropped a bit, but so's the power, so I'll just turn that up to 240. That's what I've been using as the datum. Close enough. So that's returned it to 143. Good, very good. I'll turn the radio up again. I'll just see how low I can go the voltage before it stops working. So there's 219. It's never going to get that low. I'm still going at 2 volts there, and that's dropped to 130 well within. Now I've put it on nearly 260 volts there, and we've still got 2 volts there. That's gone up to 153, absolutely perfect. Something else I need to check, this was running at about 50 odd on the test yesterday. Yeah, that's a bit hotter than that. I reckon that's getting close to 60. I'll swap the temp probe over. I've put the temp probe on there with the paper clip just to hold it on. It's been about 5 minutes and it's stabilised at 59 degrees. So I was pretty accurate with my little finger test there. I'm at the workshop and I've already made a base for this. I made this the other day. I painted the transformer here, and a little board will sit on there as well. Now what I want to do now is just cut a hole here for the board to sit on, and then you can access underneath. I'm going to cut the hole about 17mm from the edge. That'll give me enough material left to drill holes to mount this board. I've set my square to 17. Just put a mark there, and I'll just check I'm right. Yeah, I think that's good. Okay, I'll finish marking it out and then I'll cut it out. To cut this out, there's a number of ways I can do it. What I normally do is just drill a series of holes and then file it all out. I've got a cutter in there, a disc cutter. I could cut it with that, but if it slips, it then runs up here and damages this area. So I'm going to stick with this idea. It shouldn't take too long. That didn't take long at all. A pair of tin snips and I'll cut all this out and I'll have the hole. So just join the dots. That's come up well. I'll just file that out now. I've done these two sides. I'll just do this bit here, and all I've got is a bit of wood behind there to hold it, and I'll just file this flat. And I'm using the jaws of the vise as a guide. Alright, that's all finished. I need to make some ends now, and the ends are going to come up here, and I'll have switches and stuff on the front. I'll mark that out, then I'll come back and we'll cut it and fold it up. I've marked out one of the ends and I'm going to cut it and then fold it, and I'll just show you what I bought. It's a combination guillotine folder, and up the top here's some rollers, and you can roll metal or rod in the little grooves here. I hadn't seen them before. I'd seen little bench folders. I hadn't seen a guillotine before, not a little one like this. So this suits perfectly for what I do. And it's typical Chinese quality, I guess. It'll work. It's not fantastically finished, but it works all right, and it was pretty cheap. There's a guard come pressure plate that sits there, stops you getting your fingers in there, and it also pushes down, holds the material when you're cutting it. But I'll take that off so you can see what's going on. The first thing I'm going to do is cut this off here. Before I would have used some pneumatic shears or tin snips, and this stuff's pretty thick. So this will make it much easier and more accurate. Now I've got a line on my work, and it's just lined up with the edge of the guillotine there. So it's just a matter of cutting it. Here's the edge I cut, and it's nice and straight. It hasn't got any ripples in it from using snips or anything. It's good. I'm going to cut this out here now, these two little angles here. Once again, two very nice cuts. I need to notch these corners out. I'll fold the top and bottom first, and then I'm going to fold in the sides, and this part here is the folder. So this goes in here like that, then you lower that down and try and fold it. Now the problem with this design is it's a bit hard to see where your line is, so I'm using a torch and I can see it perfectly now. So it's the same before, just pull the handle down. Unfold. All set, do fold number 2. Nice. It's also a box folder, so it comes with these removable little bendy shapes, so you can just put in what you like to make up the width of the box that you're folding. So I'll change these over to what I need, and I'll fold the other two sides. I haven't got a form of the right size here, but these will work even with a gap in the centre. There it is. I might need to just use a bit of manual bending to finish that off, but it's good. So I'll do the other side. And here we go. Alright, here it is. There's our base. Now this should fit in here. Oh, look at that. There you go. It goes like that. Now here's one I prepared earlier. And that should go in there as well. So all I have to do now is put some pop rivets there, a couple on the front, and that'll be it. It'll screw into the base here. I'll drill holes in here and put some sort of nut inside, and then I can mount it. So that's my little folder guillotine. Chinese quality, yeah, it's okay. It's accurate enough where it needs to be, but it's doing a good job and much better than what I was doing before. So I'm really happy to use it. I'm not affiliated with these people at all. I've just got this online, so it does the job, and I thought you might be interested to see it. I said I was going to pop rivet this end on, but I think I'll screw it on. I want to put a wire mesh in here, and I need to be able to remove the ends, so at least one end. So I'm going to use a thing called a riv nut. If you haven't seen a riv nut before, it's like a pop rivet, but it's got a thread inside it as well. So we just put that in the hole there and squeeze it up. That's it. Undo the mandrel. And there's our rivet in there. So I'll do the other end as well. So same deal again, just squeeze it up. That's it. I have a 3mm screw, I'll put that in temporarily. I'll just put one in the other end as well. Alright. I'll square this up, put another rivet here, another rivet here, and on the other side, of course, and that should hold that, and I'll come back when I've done that. I've finished putting all the riv nuts in. I put riv nuts in for the transformer and for the PCB board, plus on the sides here, so it's ready to go as far as the base is concerned. So the next thing to do is mount a switch and a fuse, and I've also got a strain relief for the power cord where it goes in. So I need to drill 2 holes and cut out a square to put the switch in. So I'll go and mark all this up. We'll have a look at that. I've marked it out. I've got the switch there, the fuse, and then the strain relief down the bottom. I'm going to drill this out the same as I did last time. I'll just drill a series of holes. I use a smaller drill this time. File it out to its square, and that'll be okay. These ones are D-shaped fittings, so I'd have to drill them smaller and then file them out with a D flat on one side or both sides in the case of this. I've cut the holes out for the 3 fittings, so they're all right. I won't push them in because I won't get them out again. But the rest of it's finished, I think. I think that's about as far as I can go. I've ordered some perforated metal to put around the outside, but that's going to take a few days to get here. But I think overall it's turned out pretty good. And with the components in there, I think it'll be all right. I'll give it a coat of paint, and then I can take it inside and I can wire it all up. I've painted all the sheet metal black, and I can start putting it together. I drilled 2 holes here to put some LEDs in. I've mounted a tab strip on the back, and here's the LED. I've got a green one for high tension and a yellow one for low tension. So I'll poke that in the hole, bend the little leads up here to mount on the tags, and just solder them there. It'll stay there by itself. If I solder that on there, and I'll bend this one over here, and that should hold it. I'm just going to lay these on top. I'm not going to attempt to wrap them around the tag. Now that's the anode, so I'll put a plus sign there, make it easy. Alright, I'll just fit this yellow one and I'll come back. That's finished. I've soldered some wires on as well. Alright, now I can fit these components in, assuming they'll go in. Now in Australia we put the 0 at the top of the switch. That's alright, good. I'll try and get this fuse in. I think it fits. There it is. There's a nut on the back of this fuse to hold it. And the lead goes in there, but I won't put the clamp on. I need to adjust the length of the lead yet. I'll wire the power cable in, then I can mount this on the base and connect it to the transformer. Right, I've wired that up as far as I can go, and I can now mount the transformer. I've got a little solder tab on this one, and I will put the 2 little grounding wires from inside the windings onto there. I'll put the 2 screws in here, then I can wire this up. Alright, that area is all wired up. I'll put the PCB board in, and then I can wire this in. I've got some little standoffs here, so I'm going to mount it on those. Now as you saw, the PCB is mounted. I need to connect these wires into their little points on the board. So I'll do all that. There's no point me showing you that. I'll just do all that. I'll come back when it's done. I've wired that all up now and it's all done and I'm ready to test it. I've put some meters on here to check the outputs. All going well. The yellow one will be 144 volts and this blue one should be 2 volts. I'll put some power. I'll just put that to 240 or close to it. That'll do. Alright, power on. So I'll see what happens. Oop, 2 lights. Okay, the voltages, I said 144, it hasn't got the radio attached, so it's 176, and this one's 2 volts, that's right. As I said, the 2 lights are on. Yeah, everything's looking good. I think the best thing now is to attach the radio, and we'll see if it's going to work with the radio on it. I've connected the radio up, and everything's okay, I'm pretty sure. Still got the meters going here. The Variac's on 240 volts. Let's turn it on and see what happens. 2 lights, I can hear the radio.
It's funny how we
There it is.
come across new art forms. So I had never seen nor heard the anime series Ghost of the Shell until the movie.
What have we got? 143.5, okay, and 2, absolutely perfect. I'm a little disappointed, I'm 0.5 volts out on my calculation. The only thing left to do is on the back wall here is to put a power socket, and I'll run these wires into there. I'll put a plug on these wires and we can just plug it in. I have the back panel for the power supply chassis. I forgot to drill the hole here, so I had to go back and drill it and then respray it. I'm going to use one of these connectors. It's an old style connector out of an old radio. It'll sit up here somewhere and I can run the wires directly into the points here. I'll mount the socket with screws, I think. I was going to use pop rivets, but I think I'll use screws. And just do them up. Yeah. Alright. So that looks pretty neat. Alright, I'll solder these in. I've tinned the wires. I'll do the same for the 2 volt ones here. I'm using colour coded wire that means absolutely nothing. It just happens to be the wire I have. Let's put some heat shrink on there to cover those up. I've arranged the wires, I've just stuck it in the socket for a minute. I'll take them out and then attach it to the lugs. This just seemed a good way of measuring the length that I want. Just solder that on there. I'll put the other 3 on. I've soldered those on and I'll just put some heat shrink over the tabs there so we don't shock ourselves. Electrically it's finished. I need to wait for the perforated sheet to come and then I can make a cover for it. And I've got some decals I'm going to put on the front here. I've taken the old wire out and I've put new wiring in that's running through this sleeving here. And I have a plug that goes in the back of that socket. And I've just put the wires in. They're not connected yet, but I'm just lining them up to make sure they're the right colours. So now I can solder the wires into the plug. I've tinned these wires and I've got flux on the end, so they should just melt in. If I touch the end of the pin with a soldering iron, the wire should pop out. It goes. Okay, it's all done. I'll trim the ends off. Have a bit of heat shrink on the end here. I'll shrink that on. That'll hold the sleeving. Okay, that should plug in there. Very nice. I'm checking to make sure I have got the wires correct, and that looks good. That's fine. I'm all connected up. I'm going to try it. I'm a bit nervous. I'm not sure why. I think it'll be alright.
I mean, is that the point where you
it didn't
really
work for a second.
have to cut back on your car travel? Can you
Perfect.
even... Local hang up justice. Hurry, offer ends Sunday. Excludes eye exams, insurance and packages. Available in selected stores. To remove the duty on Geo 360. So, prizes. Price I pay at the petrol station depends.
There you go, it's working. Fantastic. I was a little nervous as I rewired the set, I think. So as I said before, it's all done. I just need the cover, and I'll put some decals on the front and in the back, and that's finished. I ran the radio and the power supply last night for, I don't know, maybe 3 or 4 hours, and everything worked fine. It was okay, but it was getting too hot. The area that was having trouble was where this rectifier is. It was sitting down here, down next to the capacitor. It was getting hotter than I expected, and it was heating this capacitor up. So I've put a bigger regulator on. It doesn't need to be that big. This is a 6 amp regulator. It's crazy. The other one was 2 amp and is carrying about 1 amp or so of current. So it was well within its specs. I've put this one on because it's got longer legs. So I've got it up above the capacitor. I've even bolted a little transistor heatsink on there. The other thing I did was put a 2 ohm resistor in here, and that's the line in from the transformer. So I've just dropped about 2 volts off. It had about 9. It's now down to 7. And that's cooled this off. It's cooled the 2 capacitors off. They're now running about 38 or so. This resistor here is a bit cooler, and a regulator over here is a bit cooler as well. So this is the 2 volt supply. Still the same amount of heat being generated, of course, but now it's got various ways of getting rid of it. So I think it'll be much more reliable with all these mods. I know I've gone mad with the heat sinks, but yeah, it just gets it away from all the components down the bottom. I've managed to get a piece of perforated metal, so I'm going to go outside and cut this up and fit it, and I can finish this off. I've popped out to the workshop. Here's my bit of tin. It's a bit wide, so I'm going to cut it. And the other thing is the holes are smaller than I ever wanted, but I had so much trouble even getting this bit, so I'm happy to get this. I'm considering re-drilling every hole and making them bigger, but I'll cut it to size first. We'll see how that works. Alright, let's give it a go. This should cut easily. And the other side. I was going to try and drill these holes out just a bit bigger. I'll give one a go. This is going to want to climb up the drill, so I'll go pretty fast. That's pretty good actually. That hasn't left a burr. I can deburr them anyway, but it hasn't left a burr. So yeah, I might do that. I'll open them up to this size. I've marked out the area where I don't want to drill. Around the edges I don't need to do it. So I'll just go along and just do one at a time. I'm using a smaller drill so that the larger one that I open it up with gives it more of a reaming effect than you know, pushing through. So I'll start here. I don't have anything underneath. I'll drill through the hole. Wow, that took ages. And I'm also thinking I may not open that up anymore. It's going to get too weak if I go any bigger than that. I'm going to leave this. These holes are plenty big enough. I don't need to go any bigger than that. I need to go around and just deburr all these holes. That's another half hour of my life gone. But I think it'll be alright as it is, and there's plenty of cooling there. I have a big drill here. I'll sit here, put the radio on, and just twirl that. Each hole. I'll probably do the other side as well. So I could be here for a while. I'm just getting the last of the burrs off here, and I think we're about right. There's another one here somewhere, and it's gone now. So there's another one. Ended up putting the drill in the drill bit in the electric drill, so it was too hard by hand. Alright, so that's pretty good. I'm going to bend this. There's a mark there, there's a mark there. It's on the holes, so easy enough to put in the bender. So I'll do that. Okay, I've set that up. Let's bend it. Bend it just a little. We'll see if it fits. That looks good. Alright, good. Now my plan was to put a slot in here to pick up that screw and the one up the front here, and then I'm going to put a screw on the top to hold it down. That's got a plastic coating on it. I'm going to take that off, and I am going to rub this back, and I'm going to paint it. I'm going to paint it black, of course, and I've got some slots in the bottom, drill a hole in the top here, and then I think it'll be all finished, so we can have a look at the finished product. Okay, the cover's all done and painted. I've got it on. I've put the 2 screws on the top there, and the covers come up really nice. It looks good. The big holes there, they drilled out really well, nice and smooth. I used the label maker to make the labels for the front. That one there's the water transfer. But because it's black, it's difficult to make any sort of water transfer you can see because you can't print white, so they'll do. Overall, I'm happy with it. It works quite well considering my lack of knowledge in this area. My new Bender guillotine thing I'm falling in love with. As I said, it's not the best quality, but it works really well, and I could not have made this without using that. I haven't done a circuit diagram, and I don't intend making a circuit diagram, so don't bother asking because I just don't have one. The regulator is the LM317. There are loads of circuits on typical users online. All I did was add a rectifier and a pi filter to smooth it out and supply the voltage. The 144 volt one is 2 diodes and a pi filter, and that's all that's in that one. I did add a bleed resistor to that 144 volt because if you take the 2 volts away, the 144 will just sit there until you put your finger on it. So the bleed resistor bleeds it off in about 5 seconds. I had a lot of fun making this, and I hope you enjoyed watching it. It was supposed to be a 10-minute part of the main video, and it's turned into its own video. Anyway, just a little bit different to normal, and I hope you did enjoy it. And I hope you can join me next week for part 3 of my Bush BP5 radio adventure.